Hello everyone, this is KS Reddy from the Department of Mechanical Engineering. This video is the part of the video series for unit number 3 of the course Engineering Mechanics. The content of this video is the concept of centroid. Let's begin this. Consider an object of very simple shape, and I assume this as a homogeneous body, that is, with properties same everywhere, and the body is of uniform thickness. Now I have divided the body into 3 prismatic elements, and for the better visualization I have shown those elements with colors as shown in the figure. As my intention is to calculate the position of the center of gravity of the body, I am considering a Cartesian coordinate system represented as shown in the figure. As you know, each element is acted upon by gravity pull, and in the figure it is represented as F1, F2 and F3 for the elements 1, 2 and 3 respectively. So these 3 forces constitute a parallel system of force, and from the previous lecture we know the resultant of these 3 forces passes through a point which is known as center of gravity. This picture shows x and y coordinates of each and every individual gravity pull on the elements 1, 2, 3 points, and the resultant of all those 3 forces is represented as R as shown in figure, and C represents the point through which the resultant R passes, and by definition that point is the center of gravity. XC and YC are the coordinates of that center of gravity. Now the magnitude of the resultant force is simply the algebraic sum of all the forces in the system. We know that from the concepts of unit 2 and unit 3. So R is given by the sum of all the 3 forces because they are in same direction. So positive sign comes for all the forces. Now if I take moment of all the forces in the system about any point on x-axis, I can write that moment as algebraic sum of moments of all the forces, that is given by F1 y1 plus F2 y2 plus F3 y3. Since the resultant should also have same magnitude of moment about the same point on x-axis, we can write moment as R times yc. So equating the above 2 equations, we get the center of gravity location as F1 y1 plus F2 y2 plus F3 y3 divided by F1 plus F2 plus F3. Similarly, for x coordinate also we can apply the same procedure by considering moment about any point on y-axis, and we can get the equation xc is equal to f1 times x1 plus f2 x2 plus f3 x3 by f1 plus f2 plus f3. So here f1, f2, f3 are the gravity pull on each and every individual element. Considering rho as density, g as acceleration due to gravity, we can replace F1, F2 and F3 with the expression for weight as shown in this formula. So here F1 is represented as rho g delta A1t, where delta A1 is the area of the element, T is the thickness of the element. Similarly, F2 and F3 will be also replaced like this, and as you can see from this numerator and denominator, we can cancel out density and thickness as well as g, so that the equation can be simplified to this equation. As you can see, the only terms involved are areas of each and every element and the distance of the point of action of gravity forces on each element from the respective axis. So if I use a simplified notation, yc can be expressed as summation over I from 1 to 3 delta ai into yi by total area. If I divide the object into n number of elements, the same procedure can be applied, and I will be getting the formula yc is equal to sigma I is equal to 1 to n applied over delta ai into yi by sigma I is equal to 1 to n delta ai. Similarly, xc can be obtained from this formula. So if the body is of small thickness and is of homogeneous properties, then there is no need to consider the three-dimensional body. Simply we can consider the plane figure and we can calculate the location of center of gravity. Since the plane figure cannot have the weight, the word center of gravity is misnomer for such figures. Hence, a word centroid is used to represent the location of center of gravity of such plane figures. So, instead of considering three-dimensional figure, we can go along with a simple plane figure as shown here. So, centroid is nothing but center of gravity concept applied to bodies of negligible weight because of their very infinitesimal thickness. So now the question for you is, what is the difference between the terms centroid and center of gravity? That is, the term center of gravity applies to bodies with mass, that means of considerable weight, and centroid applies to plane areas. Thank you.